As software evolves, there tends to be more and more unused features and components added to repositories. This phenomenon is called bloat. One of the major reasons for bloat is the development methodology where a set of features are packaged into libraries. Bloating has many adverse effects, such as increased code size, exploitations via deserialization attacks, and harder management. There have been many recent stories about adverse effects of bloated software. Thus, there is a need for a tool that can help in understanding bloat of applications and enable debloating. So we built WebJShrink, a web service for visualizing bloat and debloating Java bytecode. Let's take a look. This is the landing page of WebJShrink. A user is prompted to give a GitHub repository of a Maven project. Here they can enter their GitHub username, and here they can enter the name of the repository. There are three options for entry points that a user can select. Main, in the case the project is an executable application. All public methods, if the project is a library. And use test entry, if all JUnit test methods can be selected. And any combination of the three can be selected. Next, the developer can choose whether JShrink uses CHA, or class hierarchy analysis, or Spark to generate the overall call graph. CHA tends to over-approximate building the call graph, while Spark creates a more exact call graph, but is more computationally expensive. Lastly, if a user suspects the existence of reflective calls in their codebase, they can select Tamiflex or JMTrace, which helps aid in preserving the overall semantics for potential debloating. Tamiflex does this by creating a dynamic reflective call graph, which can determine what methods are called from each reflective call site, which allows us to extend our static call graph further. JMTrace is a native profiler that can capture all dynamically invoked methods. By contrast, Tamiflex only instruments a predefined set of reflection APIs and thus is considered more lightweight. Let's walk through an example. I will be analyzing and debloating the open source project QArt4j. Here's the repository for this. This is a QR code generator written in Java. So I'll note down the username and the repository name and write that in the form in WebJShrink. The GitHub username and repo name are specified. So now we have to select the entry points. We'll select all the entry points here. The next step is selecting dynamic and static call graph analysis options. I will select CHA for static analysis, and I'll select JMTrace for dynamic analysis. Once all the options are selected, we can hit submit. WebJShrink downloads and analyzes the repository. Usually this takes several minutes, but we have cached results for several popular repos for which this step is pretty fast. Once the call graph analysis is complete, several visualizations are presented to the user. On the left, there are two charts illustrating the total number of used and unused classes and methods. One can hover over to get the exact numbers. For instance, the unused classes count here is 602, whereas the used classes count is 481. The horizontal bar chart is used to understand the use of library APIs. The user can view the bloat in terms of used classes. One can click on an API, and a color-coded list of all classes in that API are presented. Classes in red are unused classes, whereas classes in green are used. This feature can allow a user to investigate specifically which classes they aren't using. After analyzing the bloat, a user can manually prune their codebase or use WebJShrink to debloat using the form below. A user can select Prune App if they would like to prune any unused application classes along with their library classes. Checkpointing is a strategy that reverses test failure-inducing transformations. Methods can be removed using three options: remove the entire method, remove only the method body, which preserves the definition, or replace method body with a message, which can be custom. Once these options are selected, a user can click the Debloat this repository button. This again can take some time. Once the debloating is complete, the user is presented with the statistics of the debloat. For instance, the library size was reduced by 19.4%. The user can also gauge the behavior preservation by seeing the percentage of tests that passed after the debloat is complete. Finally, they can obtain a zip file of the debloated repo by clicking on this button. WebJShrink provides a simple and intuitive way to visualize and understand the bloat of code bases and enables software engineers to debloat their repositories.